All right, this is an interesting question and there will be many cases, many sub cases of this question. So we have to find maximum area of a square which can be inscribed in a right triangle with sides 8, 15 and 17. So there are two ways in which we can inscribe a square inside a right triangle. Square sharing its one side with the hypotenuse of the right triangle, or there is the second case where the square shares the two sides with legs of the right triangle. Let's find area in both these cases and then we will calculate the maximum area. We will see in which case we get the maximum area of the square. So in this first case, let's say the side of a square is s units, and in this diagram this triangle AED will be similar to triangle ABC. This will be similar to triangle ABC. Why? Because angle A is common in both the triangles, and here we have angle AED as 90 degree, here angle ABC is 90 degree. So two angles are equal, these two triangles will be similar. As they are similar, ratio of corresponding sides will be equal. So AE upon AB, AB is what? 8 units, will be equal to ED. ED is S upon BC. BC is 15. So AE will come out to be 8S upon 15. Okay. Similarly, this triangle CFG will be similar to triangle CBA. Angle C is common in both the triangles and this angle is 90 degree. Similarly, this angle is also 90 degree. So CFG will be similar to CBA. Okay. Corresponding sides CF upon CB. CB is what? 15 units. This will be equal to FG. FG is S upon BA. BA is 8 units. So CF will come out to be 15S upon 8. Okay. Now AC. AC is what? AE plus EF plus FC. AE is 8S upon 15 plus EF is S only plus FC is 15S upon 8. 15S upon 8. Okay. And length of AC is known to us. Length of AC is nothing but 17. So we have 17 on the left hand side and a term containing S on the right hand side. So we can easily calculate the value of S. Solve this and we'll get the value of S as 8 into 15 into 17 upon 8 square plus 15 square plus 8 into 15, which on further solving will come out to be 4.99 units. This will be around 4.99 units. So this is the length of side of this square. Okay, we have not yet calculated the area. For that we will have to calculate a square of this value. I am leaving it to you. For now, this length of side will do for us. In the second case, we have triangle PST. This angle is 90. Triangle PST will be similar to triangle PQR. This angle is also 90. Angle P is common. That means ratio of corresponding sides will be equal. So PS is what? This overall length is 8. Length of this square is, let's say, S dash. In this case, length of a square is S dash. So PS is 8 minus S dash upon PQ. PQ is 8. This will be equal to ST. ST is S dash only upon QR. QR is given as 15. Cross multiply. We already have an equation in S dash. Just solve it to get the value of S dash as 120 upon 23, which will further come out to be 5.22 units. So if you compare the length of sides in this first case with that of this second case, you can easily see that length of this side is little bit greater than length of this side that we have got in the first case. So area in this second case will be greater than the area of a square in this first case. So maximum area when a square is inscribed in a right triangle will occur when the two sides of a square overlap two legs of the right triangles. If you want to calculate the actual value of area, you can square this value to get the area. Okay. And if you wish to calculate both these results, this one and this one, in terms of A, B and C, in terms of length of three sides, then this is what? A into B into C upon A square plus B square plus AB. This is the length of side of this square in this first case. In this case, we have S dash as 120 upon 23. This is nothing but AB upon A plus B. And maximum area will come out in this second case. Then there is this next part of this question in which a rectangle is inscribed in a triangle and we have to find maximum area of the rectangle. Okay. A rectangle is inscribed in a triangle. Now this triangle could be a right triangle. Okay. And rectangle could be inscribed in this way. And this rectangle could also be inscribed in this way. Be it this case or be it this case, in both the cases, maximum area of the rectangle will come out to be same. Okay, and that will be half of the area of this triangle. Okay, even if the triangle is not a right triangle, that is this case, even if the triangle is not a right triangle, maximum area of rectangle that can be inscribed in a triangle will be area of triangle upon 2. Okay, maximum area of a rectangle will be area of triangle upon 2. Half of the area of triangle in which the rectangle is inscribed. Even if the triangle is right triangle, this will follow. Even if the triangle is not a right triangle, maximum area will be half of the area of that triangle. Okay, let's see how we have obtained this result. So I am taking a general triangle, general triangle as in this is not a right triangle. But if in this case, if we can prove the result, then it will be valid in right triangle as well. It will be valid for all other triangles. So in this case, breadth of the rectangle is x, length is y, and height of this overall triangle is h units. So area of triangle by Heron's formula would be root of s into s minus a into s minus b into s minus c. S is semi-perimeter, that would be 10 plus 17 plus 21 upon 2, that is 24. S is 24. Area is root of 24 into 24 minus 10 is 14, 24 minus 17 is 7, 24 minus 21 is 3, and this will come out to be 84 units, 84 square units. Area of triangle is 84, which will also be equal to half of base into height. Half of base, that is 21, into height, that is h. From here we can get the value of h as 8 units. Okay. So this height is 8 units. Now in this small triangle, height of this small triangle, okay, I am talking about this triangle. Height of this small triangle is h minus this x. So height will be 8 minus x. Also, this small triangle will be similar to this bigger triangle because this base of both these triangles are parallel to each other. So this small triangle will be similar to this bigger triangle. So I can say the ratio of corresponding sides will be equal, and that will be equal to ratio of altitudes as well. So ratio of corresponding sides, this side is y, y upon this base is 21, this will be equal to ratio of corresponding altitudes, that is 8 minus x is the altitude of smaller triangle upon h, that is the altitude of bigger triangle. So from here we can get an equation, one equation in two variables, 21x plus 8y is equal to 168. Next we have the good old arithmetic mean greater than or equal to geometric mean. Arithmetic mean is greater than or equal to geometric mean. Arithmetic mean of 21x and 8y will be greater than or equal to geometric mean of 21x and 8y. So 21x plus 8y upon 2, this is the arithmetic mean. This will be greater than or equal to root of 21x into 8y. This sum is equal to 168. Put this value here, square both the sides, and we'll get 21x into 8y. 21x into 8y, this right hand side I am taking it to the left hand side. This sign will get reversed and I'll have 21x plus 8y is 168. Square of that is 168 into 168 upon square of 2 will be 2 into 2. I have squared both the sides. So xy will be less than or equal to 168 into 168 upon 2 into 2 into 21 into 8. Solve this and the value of this whole will come out to be 42. So we have xy less than or equal to 42. Overall area of this triangle came out to be 84 units, 84 square units. And maximum area of this rectangle, is what? Length into breadth, x into y. This is the area of this rectangle, which could be 42 at max. So you can see 42 is half of 84. Area of rectangle, maximum area of this rectangle could be half of the area of this overall triangle. Okay. Then there is this third case that I want to talk about, where we have a square. This is a square. We have a square inscribed in a random triangle. It is not a right triangle. We have a square inscribed in a non-right triangle. Now in this case, side of square is x, okay, and this height is h. So again we will do the same thing. This question I have already solved it in similar triangle video, solved examples. This is already there. I am solving it once again so that you can compare it with rest of the cases. So here area of this triangle, we will apply Heron's formula here. Semi-perimeter is what? 13 plus 37 plus 40 upon 2. 90 upon 2 is 45. So area will be root of 45 into 45 minus 13 is 32 into 45 minus 37 is 8. 45 minus 40 is 5. And this will come out to be 240 units, 240 square units, which will also be equal to half of base into height. We can get the value of h as 12 units. So h is 12 units. Now this small triangle will be similar to this bigger triangle. So x upon 40, ratio of corresponding sides, will be equal to ratio of corresponding altitudes. Altitude of this smaller triangle will be h minus this x, overall h minus this length x will be the height of this smaller triangle. So 12 minus x upon height of this bigger triangle is h, that is 12. We have got an equation in x. We can calculate the value of x, cross multiply and get the value of x as 120 upon 13. And area of this square will be, 120 upon 13 whole square. And this value is not half of the area of the overall triangle. Okay, it will not be half of area of the overall triangle. In which case do we get the value of area of inscribed figure as half of the area of triangle? When the inscribed figure is a rectangle. Then we get the maximum area of rectangle as half of the area of overall triangle. In this case, we have a square and area does not come out to be half of the area of triangle. You will have to calculate it in this manner. Okay. I hope all three cases are clear to you. In first case, we discussed maximum area of a square inscribed in a right triangle. So this was the case in which we got maximum area. In second case, we had a rectangle inside a triangle. In this case, we got maximum area of rectangle as half of area of triangle. Okay. Then this was the third case in which we had a square inscribed in a triangle, in a non-right triangle. Okay, so in this case, again we will calculate in this manner and we'll get the area. So these were the three cases that we have discussed in this video. I hope all three cases are clear to you by now. Thank you.